right. Hey, everyone. Thanks for joining us in the Hacker Lounge today. So today I'm going to talk about something that we think is pretty interesting, which is called MACI, which is an acronym spelled MACI. As you can see, it stands for Minimal Anti-Collusion Infrastructure. Um, and it's actually been around, like the idea of MACI has been around for a number of years already, but it hasn't really been implemented in a multi-chain modular like architecture until recently. So for those that don't know what MACI even is, like a brief example of MACI is minimal anti, as I said, minimal anti-collusion infrastructure, which is used mostly for privacy voting on chain to prevent collusion across voters. Something that can typically happen with on-chain voting is maybe you try to buy someone's vote. Say, hey, I'm going to give Chris $200 if he votes yes. Or maybe if I want people to vote for me, I can say, hey, I'll give you an airdrop if you vote for me. And you can almost campaign around that. So obviously this is a problem because you want results to actually reflect community values and not actually be like, swayed by whales or by bad actors. So what MACI does is it makes it impossible for anyone to prove post-voting cryptographically which way they voted. So for example, I would never buy someone's vote if I can actually never receive evidence after the fact from that person that they did indeed vote in the way I paid them to, right? It makes it a lot more risky for me to actually purchase their vote because I don't know if I'm getting what I paid for. It also makes it impossible for me to coerce them to vote the way I wanted to, because even if I like captured them or tried to, beat them up or do something and say, hey, like you need to vote yes for me. I'm looking at your laptop right now. Vote yes, and they vote yes in front of me right then. They can later on change their vote to no before the round ends, and I would never know. So this is like a really important piece of privacy voting anti-collusion infrastructure that we need to scale on-chain voting. And in the past, how MACI has been implemented is via ad hoc smart contracts, right? It can be deployed as a Solidity smart contract for EVM chains. It can be deployed in Rust on Solana. It can be deployed in CosmWasm as well, in Cosmos, which is something we have done for some of the very earliest versions of MACI. And this has been great. It's been a great step forward in privacy voting for Cosmos. But MACI does still have certain shortfalls. It's not perfect. It's a flawed solution. There's three main shortfalls of MACI. The first of which is that it requires a technical person to actually operate the round, right? Like an operator who is going to set up the round, who after all the votes have been cast, they're going to tally the votes, right? Which involves decrypting them, tallying them off chain, re-encrypting them, posting them back on chain, right? So not anyone can be a MACI operator. It's more difficult to do. You need to have some type of technical knowledge. And what that means is not just any ecosystem or not any person can very easily spin up a MACI round by themselves, right? They need to source an operator first, right? Which causes a lot of friction. The second problem with MACI is that the operator could collude, right? Voters can't collude, but the operator could. And that could look something as simple as not posting the results of the vote, right? They could tally the votes, and then they could just refuse to post them, or they could delay in posting them, or some other thing that would sacrifice the integrity of the round. And then the last thing is that the operator, because they're the ones decrypting the votes, tallying them, and re-encrypting them, they're the one person that technically does know the identities, or at least the addresses, on-chain addresses of the voters, right? No one else does, none of the other voters do, but the operator does, right? And they ultimately could tell people, which you don't want to have happen. So there's still some type of trust assumption in MACI, even though the scope of attack or the scope of collusion has been minimized substantially. So the last couple of years we've been thinking, well, how can we solve these problems and build a more scalable version of MACI that can actually service the multi-chain world, particularly like Cosmos? So what we've done is we've actually launched our own L1. It's called Dora Vota. It's on mainnet right now. We have 12 validators. And what we've done is we've actually required all of our mainnet validators to run MACI operator software as a sidecar. Right? This is somewhat similar to how DYDX requires validators to maintain an order book, or how SEI requires validators to maintain price feeders as part of the hardware requirements and eligibility requirements of being an active validator in the set. So all of the Dora Vota validators run aMACI operator software. So what this does is it solves the first problem I mentioned about having to source a technical operator previously for aMACI. Now, because all of the validators on Dora Vota are aMACI operators themselves, this creates something called operator as a service. So now anyone can come to Dora Vota, spin up a aMACI voting round for whatever purpose that may be, and the operation of the round is automated via our validators, right? The validators themselves are the operators, so no one has to worry about actually having to source their own technical operator. So now anyone can spin up a aMACI round, even if they're not a technical person, which is obviously a huge UX benefit. The second thing is there's now an economic reason for the operator not to collude, right? Because now if a validator tries to collude or tries to delay posting the results of the round, they'll be slashed, which they certainly don't want to have happen. And then the third thing I mentioned, which is like operators knowing addresses, that's the last thing we look to solve, and I'll get to that towards the end of the presentation. But what's next for aMACI in general on Dora Vota? Well, the first thing we're looking to do is expand more open source front ends of this underlying protocol. Right now we have our basic front end, right, where you can go on Dora Factory, vota.dorafactory.org. You can explore all of the active aMACI rounds on Dora Vota, and you can even deploy your own aMACI round if you're interested in having some type of on-chain vote. The next thing is, as I said, the expansion of this front end. I think ultimately we would love to see aMACI being used by more and more governance platforms. There's a lot of them out there existing that, either for proposals or for on-chain voting, have some type of really sexy front end, like voting schemes. There's a lot of them out there like Commonwealth, DAO, Tally, even Snapshot, which is more Ethereum aligned. But none of them actually have native privacy voting under the hood yet. So they can actually be like open source front ends for aMACI long term, and we can help scale this to the entire crypto ecosystem. As I mentioned, this is kind of what I'm saying, where being an operator is a tough job. It requires some technical knowledge. So obviously having our validators be the operators is something that really makes aMACI accessible to everyone. We're starting to see aMACI get adopted, specifically from the Cosmos community. It was used in the most recent Confio hackathon in Berlin for judging to decide what hackathon projects were the best there that should win prizes. And it's also currently being used by the Cosmos Hub community for the aZQF program, which is a $1 million program where over the next 2 years, we're distributing early stage funding in conjunction with the Cosmos community and Atom Accelerator DAO to public goods, open source, decentralized, non-commercialized public goods that service the Cosmos Hub. So actually, Atom stakers and Atom holders can vote directly with their native Atom token for what early stage projects or public goods they think are deserving of decentralized community funding. And this is facilitated via aMACI. So already in the first round that we did this, we had over 2,000 voters sign up and over 18,000 individual votes cast, all with privacy-enabled aMACI on Dora Vota. Big news, it's also coming to Celestia. We just concluded the Infinite Space Bazaar hackathon with Celestia, and out of all of the winners are actually participating in the aMACI round for extra continuation funding, where TIA stakers can actually vote for which hackathon projects they think are deserving of receiving continuation funding. So if you want to participate in this aMACI voting round and you're a TIA staker, feel free to scan that QR code and you can cast your vote. And I'll actually even demo that for you in a couple minutes here so you can see how it works. Don't forget to participate in the aZQF round as well, the one that's already live. It's going on for the next 2 years. With the passage of Cosmos Hub Prop 917, we have $1 million that we're distributing to early stage public goods in Cosmos. This is actually the largest experiment of on-chain voting in the history of Web3. So if you want to participate, either as a voter, as a Cosmos Hub community member, as an Atom token holder, you can. Or if you're building a public good in Cosmos and haven't applied yet to receive decentralized community funding, highly recommend you do so. The last thing I mentioned, the one problem I haven't addressed yet, is that the operator, even if it's a validator, can still see the addresses of the voters. This is the hardest problem to solve, but one of the most important, because you need to make sure that votes are private from every single person, the operator included. So what we're working on now shipping is something called anonymous aMACI, or aMACI for short. And with aMACI, after voter sign up, voter addresses are actually automatically scrambled prior to the operator even seeing them. So now anonymity is preserved for every single participant in the voting round, which is a huge benefit over just traditional vanilla aMACI. So this is what like the new version of aMACI that we're going to start shipping now, and replacing old aMACI with. It's a really large improvement, especially in terms of like how well privacy is preserved. So that's kind of the end of the presentation. But if you're interested in seeing how aMACI works live, I'd love to show you really quickly. Just bear with me one moment. Okay. So here is our existing front end for Dora Vota aMACI. This is the Celestia aMACI round I mentioned earlier. You can see on the left-hand side, these are all of the winning projects from the Celestia Infinite Space Bazaar Hackathon. And there's $10,000 that's waiting to be distributed to the winners of this aMACI round. And we've invited all Celestia stakers to be able to participate in this voting round. So if you're a Celestia community member, you're a Celestia staker, you can actually vote. Your voting power depends upon your stake weight, how much TIA you have staked. And you can actually decide for yourself which one of these projects you think is like worthy of receiving continuation funding. So if you want to vote in this round, it's pretty easy. You just come to the Vota landing page, you connect your Kepler wallet, you're assigned a number of voice credits depending on how much Celestia you have staked. So in this wallet, I've been assigned 50 voice credits. I don't know if you can see that right there, but you see 0 out of 50. It's because I haven't voted anything yet, but I can cast a total of 50 votes. And I actually can select which projects I want to vote for, right? So say I want to vote for Sloth Chain. Maybe I want to vote for Celestia Hubble, which is a new like next-gen Celestia block explorer. And maybe I want to vote for something like, I don't know, ODS Visualizer, right? These are the 3 projects I like. I can cast along a quadratic curve how many votes like I think each project should receive, right? And the reason it's quadratic is because you don't want someone who has, so much TIA staked to just be able to stake that full amount very easily. You want to make it a little bit more difficult to make it more fair to smaller stakers. So even though I only have 50, even though I have 50 voice credits, it's a quadratic curve. So that means like the max I could actually cast, right, to any particular project is really only 7, right? Because 7 votes actually costs me 49 voice credits, right? So it makes you have to be a little bit more selective and deterministic about what projects you actually want to support. So say I want to cast 4 votes towards Sloth Chain, 3 votes to Hubble, and then 2 towards ODS Visualizer, right? That's going to cost me 29 voice credits, and then I submit, approve the transaction. One moment. Okay, and now the vote's been successful, and I've cast these votes to these chains or to these projects. I can overwrite these votes and revote until the round ends. So that's something to note. And if I want to view the details of this round, I can click this right here. Here's the round. You can see I just made this transaction right here. I had a sign up and a vote. I can view the TX hash. You can see how much Dora token it cost me to vote. It cost me 6 Dora, which was covered by a gas station on Dora Vota chain, little chain abstraction, fun little aspect of it. Even if you don't have Dora, you can still vote. But this is the transaction hash of the vote I just made, so you can now see it. That's basically it. That's how it works. So the cool thing is anyone that wants to host a private voting round can do so directly on Dora Vota. Any single Cosmos chain can pretty easily integrate with Dora just via an IBC channel. And we look forward to bringing this to more ecosystems in the future and hopefully encouraging more people to vote. Any questions? If not, that's all good. All right. Thank you.